Welcome to this explainer. Okay, so if you've ever stared at a chunk of Python code and thought, what even is this secret language? Or maybe you've wondered why the word self is literally everywhere, well, you are in exactly the right place. Today we're taking the sometimes intimidating world of object-oriented programming, OOP for short, and totally demystifying it. We're going to translate all that dense technical syntax into an intuitive everyday life cycle. By the end of this, you won't just understand how Python objects work, you're going to see them almost like living, breathing things inside your code. Let's get into it.
Okay, let's dive into this. Here is our roadmap. We'll kick things off with Welcome to OOP, followed by the class method and the power of self. Then we'll look at birth and death, and finally wrap the whole shebang up with the OOP big picture.
Welcome to OOP. So, if you've ever written a script that just kept growing until it turned into a tangled mess of spaghetti code, yeah, we've all been there. OOP is absolutely your cure. At its heart, OOP lets us build programs exactly like we organize the real world. Think about it. Out there, we have cars, students, bank accounts, right? Well, OOP lets you create digital versions of those exact things. This makes your code incredibly reusable and modular. Instead of rewriting everything from scratch every single time, you just reuse the blueprint. And because everything is neatly packed into these objects, it's way easier to maintain and extend later on. Honestly, this is why OOP is the absolute foundation of modern software engineering. It brings order to the chaos of your code.
Moving right along, Section 2, the class method.
All right, let's demystify some jargon. A class method works with the class itself, not with the individual objects. Think of the class like a giant factory, and the objects as the individual products that factory makes. A class method, that's your factory manager. It cares about things affecting the whole factory, not just one specific toy on the assembly line. You could spot these super easily in Python because they're defined using the special tag @classMethod, and they take CLS, which is just short for class, as their very first parameter. Basically, they handle the big group-level data.
Let's look at a concrete example using a student class. First, we have count equals 0. That is our group-level data right there. Every time a new student is created, our init function adds 1 to that count. But then look at how we use the class method called show_count, passing in that CLS parameter. This method's entire job is just to print the total number of students. It doesn't care about a specific student's grades or what their name is, it's just tracking the total student population.
And this brilliantly illustrates the cause and effect here. The result is exactly what we'd expect. Because our code created two distinct students, student 1 and student 2, when we ask the class method to show the count, it gives us a total of 2. The class method successfully stepped back, looked at the whole group, and counted multiple student objects for us. It gives us that ultimate bird's eye view.
Which brings us to Section 3, the power of self.
If you've spent literally any time looking at Python, you have definitely seen the word self everywhere. So what actually is it? Well, self refers to the current object or instance of a class. It's the very first parameter of every single instance method. You know, I like to think of self as a personal ID tag for your objects. Now, interestingly, it's not actually a strict keyword in Python. You could technically name it anything, like me, this, or even potato. But using self is a massive universal convention. If you use something else, other Python programmers are definitely going to look at you funny. It's basically how an object says, hey, this is my data, not anyone else's.
Let's see how this plays out in practice. In our student class, we have an initialization method that takes self and a name. Inside, it says self.name equals name. When we create student 1, S1, we pass in the name Saisha. Then when we create student 2, S2, we pass in Samruti. Because of self, the program knows exactly how to tell these two individuals apart. When we call the display method, self acts almost like a mirror, reflecting only the specific student that is asking. So the crucial takeaway is what happens when the code actually runs. When S1 calls display, self grabs the name Saisha. When S2 calls it, self grabs Samruti. The data never gets mixed up. Self makes sure the correct, unique data is pulled for each individual object every single time. It's literally the anchor of personal identity in OOP. Without that anchor, Saisha's grades might accidentally get swapped with Samruti's, and nobody wants that. Self completely prevents that data collision.
All right, Section 4, birth and death.
Let's directly contrast two very special methods. First up, we've got init. This is the constructor. Think of this as the actual birth of our object.
Going back to our analogy, this is the exact moment a student enrolls. It runs the second the object is created, sets up the variables, and it only ever happens once per object. Then, to contrast, we have del. That's the destructor. This is the death of the object. Or, to keep it a bit lighter, when our student officially graduates and leaves the system. It runs when the object is destroyed, and its main job is cleanup, just making sure no memory is wasted. Let's walk through this complete life cycle. We have our student class. The init method is set to print created, followed by the student's name. The del method prints destroyed, followed by the name. Then, we trigger the birth by creating student1, Saisha. And right after that, we manually trigger the death by calling del on that student. Normally, Python handles deletion automatically in the background using something called garbage collection. But here, we're doing it manually just to force the program to run through the whole life cycle back to back.
Now, what's really interesting about this is how beautifully it mirrors the object's super brief life. We get created Saisha, the very millisecond the init constructor fires, and immediately after, destroyed Saisha pops up when the del destructor executes. The program enrolled the student and then instantly cleaned out their desk. Hey, hopefully because they graduated in record time, right?
So we can see how this forms a really solid, reliable framework. Every single object you ever make in Python goes through this three-step linear process. Step 1, the object is created, and init sets the whole thing up. Step 2, the object is used, maybe doing math, maybe talking to other objects. And step 3, the object is destroyed, and del cleans up the mess. Cementing this simple three-step life cycle in your brain makes writing complex software feel infinitely more manageable.
Finally, Section 5, the OOP Big Picture.
Let's bring it all together. Here are the core building blocks we've tackled today. You've got the class method, which uses class to take a step back and manage that macro class-level data. You've got the self argument, zooming way in to make sure every single object keeps its own unique identity. And of course, the lifecycle managers, init to handle birth and setup, and del to handle death and cleanup. When you put them all together, these tools give you the absolute power to organize, manage, and scale your code with just incredible clarity.
Which leaves us with a question to ponder. You now have the blueprints for modeling the real world right inside your computer. You get the macro, the micro, the birth, and the death of data. So how will you use the life cycle of objects to organize your next big coding project? Take these building blocks, open up your code editor, and start bringing your own digital worlds to life. Thanks so much for joining me on this explainer. Keep learning, keep coding, and we'll see you next time.